Okay, we are getting very near the end. It's our final session. What a long, deep trip it has been. Our final topic is something which is not at all topical or of any broad interest to anybody, but we just thought we'd talk about it for the hell of it. It's the linguistic and cognitive capacities of large language models. We've got 4 great talks for this session, each of which will be 15 minutes, followed by 10 minutes of discussion. Our first speaker is Anna Ivanova of MIT, talking about formal and functional competence in large language models. Take it away.
Thank you very much. And I'd like to start by thanking the philosopher organizing this for bringing together this amazing crowd of neuroscientists and cognitive scientists and psycholinguists and AI experts to talk together about intelligence, artificial and biological. I think the interdisciplinarity here was far greater than what I expected. So it's been really amazing so far. So I want to talk, like many people before me, about large language models. And I'm going to start by thinking about the relationship between language and thought in humans. In humans, during communication, we face this fundamental issue. Other people's minds are a black box to us. I have no idea what each of you is thinking right now. And you don't really know what I'm thinking. But we can bridge this gap through language, through communicating with one another. So I can look outside, I can see that the sky in New York is blue today, and I can say the sky is blue, and you will have a representation of the blue sky in New York in your mind. So this miracle happens every day, happening right now as I'm talking to you. But one other thing that happens during this very communication process that sometimes goes overlooked is that the recipient of the message, in addition to receiving the message itself, makes all kinds of inferences about the mind of the speaker. How did they know that the sky is blue? Why would they say that? What was their intention? What were they thinking at the time when they were making the utterance? And so we don't just receive the linguistic message, we are constantly inferring the thoughts underlying that message. And this process is very helpful to us. We want to fill in the gaps. We want to know the minds of other people, even if the linguistic communication is impoverished. We don't get all of the signal with the message. And of course, this tight link between language and thought has been made prominent in AI through the Turing test. The Turing test is a situation where an observer needs to decide whether they're speaking to a human or a machine simply through language. So they use language to get at the content of the underlying thoughts. And this is often a valid inference. We can use language as a reflection of the underlying thinking process. But if we think that this relationship is too close, we are subject to certain kinds of logical fallacies. One fallacy is going from an observation that somebody or something is good at language and assuming that they're good at thought. And we see that in humans when we might listen to a speaker that's really engaging, that's very fluent and coherent, but actually their speech is vacuous, happens all the time. And unfortunately, this is also a phenomenon that's happening very commonly in AI. A New York Times article last year described this very beautifully. When you read the algorithm creating original sentences on the role of metafiction, it's hard not to feel that the machine is thinking in some meaningful way. So we are tempted to mistake this fluent, coherent, beautiful language for fluent thought. And this is arguably the evidence why the Turing test is not considered a very useful test today, because it's really all too easy to trick humans into thinking they're speaking to another human just because the chatbot is very good at this kind of interactive dialogue tricks. The second fallacy is observing a failure in certain kinds of thinking and then making the conclusion that the language is bad as well. And so that we see all the time when we see certain critics of, say, large language models or AI systems more generally, say large language models, say that they fail at some kind of task, say a math task, and then dismiss them altogether as models of language. And one famous example of dismissal of these models altogether is, of course, Noam Chomsky, who in 2019 and just a couple of weeks ago said, does it tell you anything about human language? 0. So just because this is not an AGI system, it's completely useless as a model of language. And so in this project, we set out to challenge this conflation of language and thought using this evidence from neuroscience. We think it's worthwhile to try to separate linguistic processing from broader kinds of human cognition. In the brain, language processing takes place within its own separate network. This is evidence that goes all the way back to Broca and Wernicke in the 19th century. Many studies since then have pointed down this network that seems to be responding to language at different levels of granularity, words, phrases, and sentences. It responds during both listening and reading, and it responds during both production and comprehension. Moreover, this network responds to all kinds of languages. This is a beautiful study by Sayama Dima, Ayash, and others that came out last year, where they measured responses to 40 different languages. Not all of them are shown here. We also know from other evidence that sign languages also activate this network. So this is a really general network responding to all kinds of languages and all aspects of language processing. But this network is very selective. We see from neuroimaging evidence that its response to different kinds of language is very high, but its response to other cognitive tasks is very low. In particular, it has low responses to math, logical reasoning tasks, various kinds of problem-solving tasks, conceptual knowledge. And this really suggests that this network, despite its generality when it comes to different kinds of language, is selective when it comes to non-linguistic processing. And in addition to neuroimaging evidence, we also have evidence from patients who have damage to the language network. So this is a top-down view of some of these brains. Often they get a lesion as a result of a stroke. In certain cases, this lesion can be very large, and their linguistic abilities are essentially destroyed. But if the damage is restricted to the language network, their ability to think and reason in many other domains remains intact, providing powerful evidence that language and other cognitive tasks, other cognitive functions are distinct in the human brain. But of course, we're not making the claim that all of language processing happens within this one network. Language is not an end goal of itself. To really understand the sentence, it's not enough to just process its linguistic features. We need to then be able to pass on this information, to store it in memory, to use it to plan and to act, and to make inferences. So for example, we want to also recruit a network responsible for social knowledge and reasoning and inferring the intent of our interlocutor. We want to engage the network responsible for situation modeling, tracking who the characters are in the narrative or in a conversation. So keeping track of information over longer periods of time. We recruit all kinds of systems responsible for world knowledge, including grounded world knowledge, which was the subject of the debate on Friday. We use a system responsible for reasoning and problem solving, so the kind of abstract problem solving that Nick Shea talked about this morning. And there's some evidence suggesting that conceptual reasoning and semantic tasks also recruit a potentially specialized system. And so in everyday life, we have constant interaction between the language network and all of these other systems that we need to use language in a variety of real life situations. And so what we can do is we can take this picture and use it to draw insights about artificial systems. We can say, if all of these capacities exist in humans in various ways, what about large language models? Are they good at these capacities? Are they good at them to the same extent or not? And so one thing we propose to divide these capabilities into two camps. One is what we call formal linguistic competence. So language-specific processes that are responsible for core language knowledge and are processed in the language network in the brain. And another camp is functional linguistic competence, non-language specific processes that can continue in the absence of language or even on non-linguistic inputs, but are nonetheless essential for real life language use in the world. And so just to give you a couple of brief examples, the sentence, the keys to the cabinet are on the table, knowing that the verb here is are and not is an example of formal competence. An example here, 14 birds were sitting on a tree, 3 left, 1 joined. There are now 11 birds. 11 is wrong, it should be 12. Knowing what number should go here is an example of functional linguistic competence, specifically mathematical reasoning, even though the input and the output is in the form of language. Okay, so I'm just going to briefly survey formal and functional competence in large language models, and we have much more in our position review piece. So the example I gave, the keys to the cabinet are on the table, of course, was made popular by Tal Linzen and a large body of work showing whether large language models can capture these kinds of dependencies. And the reason why it's hard, as he said, is because this relationship is hierarchical. We're not just matching the verb here to the nearest noun, the cabinet, which is singular. Instead, we need to infer the actual dependency for keys, which is plural. And so ChatGPT, for example, has seemed to have mastered this capacity. So far beyond the houses, the person who has the cats, that the dogs with the cute faces and fluffy tails chased. So tons of intervening information, tons of intervening plural nouns. And yet the model knows that the verb here needs to be is, probably worried, referring back to person for the sentence to be grammatical. And there are many structured evaluations. So one example is BLIMP, the benchmark of linguistic minimal pairs for English, which tests a large number of linguistic phenomena that are essential for formal linguistic competence. And back when the paper came out, GPT-2 was already getting pretty close to human performance. And the latest batch of models, as evaluated in the Helm framework, they perform even better, not exactly at the human level, but very, very close, depending on the phenomenon. So that makes us conclude that large language models have essentially mastered formal linguistic competence. And of course, in your everyday experience, when you read outputs by these models, they're grammatical. They rarely make grammatical mistakes. So that's what we refer to when we say that their formal linguistic competence is good. Now, what about functional linguistic competence? Here, we're going to consider two domains, formal reasoning and world knowledge. In the paper, we consider four. Of course, there are many, many more domains that you might want to think about and apply to modeling AI, to studying in humans. These two perhaps have been the most talked about. One of them, I think, is very easy, and the other one is kind of hard. So the easy one is formal reasoning. This one is the plot from the GPT-3 paper, where they showed how well their models performed on various kinds of arithmetic tasks. And the largest model at the time performed really well at 2-digit addition and subtraction. It performed okay on 3-digit addition and subtraction. But when it came to 4 figures, its performance plummeted. And similarly for 2-digit multiplication, or even for single-digit operations that required more than one step, so 2 or more steps, the performance was very low. And so, of course, the models today are getting better, but we know from, again, our interactions and some of the later evaluations that even simple mathematical tasks are not fully solved by the systems today. So Gary Marcus, as always, provides helpful examples. This was right after the update to ChatGPT at the end of January, where they said they boosted its mathematical reasoning. And so Gary Marcus gave it the problem. I went out to lunch the other day. Sam, Alice, and Barbara were there, plus 3 other people I didn't know. How many people were there in total? There were a total of 8 people at lunch. This answer is wrong, whether or not you count yourself. And that anecdotal evidence suggests that these models still struggle with formal reasoning, especially the one that requires multiple steps. Now, what about world knowledge? World knowledge is a harder case because, of course, a lot of what we know about the world is present in the training data. So even memorizing bits of text from the internet will give you a lot of world knowledge already, and we shouldn't dismiss that. So these models do learn a lot about the world. The problem, though, is that this knowledge is brittle, biased, and incomplete. And so just to give you a couple of examples, one is that the model can be misprimed. So if asked what the capital of Texas is, it might say Austin, but if primed with Boston, it might say the capital of Texas is Boston. more recent systems, for example, will change the answer depending on whether or not the conversation that's being simulated is with an expert or with a layperson. So if it's with a layperson, the system is more likely to make mistakes, which makes sense because, of course, it needs to be able to emulate the dialogue consistent with who the speaker is. But it just shows you that it doesn't actually have a single consistent internal knowledge base that it's tapping into. And another example is paraphrasing. So Seinfeld originally aired on or Seinfeld premiered on are two queries asking for the same thing, but oftentimes the model will give you different answers, in this case, different networks, depending on how the question is phrased. So this knowledge is not robust. And I'm going to skip that and say that large language models, they struggle with many aspects of functional linguistic competence, including formal reasoning and robust systematic world knowledge. Now, the last thing I want to talk about is what implication does this formal versus functional competence distinction have for building and evaluating models in the future? And one implication is for building models. And we argue that models that will use language in human-like way will mirror the human brain architecture broadly by being modular, by having or developing modules for language processing, formal reasoning, social reasoning, etc. And maybe this architecture will be built in, but maybe it will emerge over the course of training with the carefully curated set of training data and objective functions. So we don't necessarily say you have to build it in advance, but we think these are useful capacities to try and induce in models instead of just having one objective function and hoping the model will learn to do it all. And the second claim is that we need targeted benchmarks. So formal and functional competence, hopefully I've shown you, are not the same. They're distinct. There is no reason to think that the model will succeed at functional competence just because it succeeds at formal competence. And so we need to be able to evaluate them cleanly and separately, dissociating them. And so for formal competence, we have the benchmarks like BLIMP and Syntax Gym and others. For functional competence, we have a lot. Big Bench was mentioned earlier. We have some common sense benchmarks. I would argue we still have work to do at cleaning them up and having them isolate specific functional competence capabilities. So to sum up, formal competence is knowledge of linguistic rules and patterns. Functional competence are non-language specific skills required for real-life language use. And this distinction is grounded in neuroscience, can help us clarify the discourse around large language models, and suggest a way to build better language models. I'd like to thank the team behind the paper, especially my co-first author, Kyle Mahowald. The paper is online, feel free to check it out, and thank you for your attention.
Questions?
Yeah, you showed that that case of long-range dependencies. As I'm sure you know, Stan DeHaan published a paper not too long ago using GPT-2, showing pretty bad failure in subject-verb agreement across some intermediate, hierarchical tree structure parts. So I wonder, I assume your results are from GPT-4. Is that right?
No, the results are mostly from GPT-2, and then the BLIMP results are from a variety of models that are on Helm.
Okay,
so
well,
whatever is on there right now.
Whatever
GPT-4 is not there yet. Yeah.
Whatever it is, what's the difference between what DeHaan did and what you did? And if yours is in a much later system, then I wonder whether there is some longer range dependency that they can't do.
Yeah. So this is why I said in the conclusion that they have essentially mastered formal linguistic competence. I don't think we can ever say that they will master 100% of it. And there are definitely exceptions. Yeah, I think this work is maybe the most prominent example showing that maybe they're not quite as good as we would like to think, but it's still impressive, I would say, how far they have gone on the way toward functional linguistic competence, right? Especially given their training and all the linguistics debates where people argue that it's impossible. So I wouldn't say they're perfect. And it's interesting because, of course, they mirror human-like data use, so language use. And so it does make me wonder to what extent, how often do humans use these kinds of longer range and usual dependencies? And so my guess would be that whatever humans are better at, these models will also be better at.
What the Vaughn is arguing is the systems do not have those hierarchical trees.
Yeah. I'm not making claim. I'm actually not making representational claims here. My claims here are purely behavioral. Do they behave according to the rules of here English grammar, right? And so whether or not they have trees is not. I don't think it matters for this question here.
My question is related, but maybe the flip side. Your examples for functional and competence were from 2020 and 2021. And obviously things have changed a lot. So is your claims, when you're using the word LLMs, is your claim restricted to GPT-2 or maximum 3 and below? Or have you at all validated your paper's claims on GPT-4?
Yeah, so the review paper has been written over the course of 3 years, and so I think we kept like adding on evidence over this time, of course, as the models kept evolving. From what I see, so for GPT-4 we don't have the data yet, right? It just came out. So far, from what we can see, a lot of the problems are still there. All the Raphael's example on code that definitely makes us question things. One thing that I think is really important is knowing that the latest batch of models, so GPT 3.5, ChatGPT, GPT-4, are no longer trained just on word and context prediction. And our claims really center around these models that are predictive models. So the proposal that we make for emergent modularity, where we say, look, you need multiple objective functions, you need carefully selected training data and not the entire internet. That is exactly what OpenAI seems to be doing right now, where they're giving targeted feedback on specific domains, specific kinds of reasoning tasks, theory of mind tasks. I'm sure they're doing that. A lot of safety areas and safety concerns. And the data is highly curated, and the objective function is no longer a simple next word prediction function. So I think with these models, we actually do have to take a step back and reevaluate and think what other capabilities they have developed versus not. That said, I think that's also not necessarily the most valuable contribution we're making. The contribution we're making is really the distinction between formal and functional competence, knowing that they're separate, that we need to evaluate them separately. And when we build models of language use, we want models that have both formal.
We should go to another question. Yep.
Thank you for the wonderful talk. So when we're talking about maybe modularity emerging through the reinforcement learning with human feedback, would you expect like a functional modularity within the network itself, or is this a more sort of abstracted sort of modular behavior?
Yeah, that's a good question. I think, and in neuroscience, of course, there is a lot of debate about whether things need to be spatially together if they're doing the same function, or if a distributed system is good enough. I don't have strong opinions at this point. It does seem that having things together that do similar computations is more efficient, and therefore a model would benefit from. And somebody already mentioned Robert Yang's work on emergent modularity in recurrent neural nets. So I think that's an example of that. I think if the network is allowed to develop distinct modules that will make it more efficient and do the task, it will do so.
Okay, maybe time for one more quick question.
Sorry. Okay, I hope it's quick. Could you put the slide up with Gary Marcus and the out to lunch slide? So I was thinking back to the debate on Friday about, sort of what AI can sometimes reveal to us about our own human biases, which I think the response was there's no universe where a machine learning person would want less data, but that's fine. But just looking at this one, I was thinking a little bit about who counts, right? So there's math in the abstract, adding up numbers. And then there's sort of, like you said, all these different social contexts, et cetera. And I feel like this answer, I could argue that you also want to count the server. So does the server count, right? So if I say I went out to lunch as a native English speaker, when I say I went out to lunch with other people, I typically mean we went to a restaurant. So if I say we're going out to dinner, out to lunch, it means restaurant. So I was just saying, I thought this was an interesting example because when we think about where world knowledge is in, potentially, I would say the server was at lunch present. So sorry.
This is excellent because I think the main point we're making is that formal and functional competence are distinct and are a useful distinction to be making. The second point is that because of this process of constantly inferring the mind behind the words, we are really tempted to infer intentions of these models, even when we know how they work. We're like, oh, but maybe they thought this and maybe we thought that. And we have like a short opinion piece that Blake Lemoyne, the Google engineer, saying that Lambda is sentient is also an example of over-interpreting the words. And even when it doesn't quite make sense, we kind of want to try to make it fit. So I would argue that it's not necessarily always wrong, and it might be true, but we have this fallacy that we fall on all the time, and we should be really careful about it. So not necessarily that it's wrong, but we should just be very wary of this kind of reasoning.
Okay, thank you very much. And our next speaker is Nuhu Osman Attar from the University of Pittsburgh, who's going to speak about, do language models lack communicative intentions?
Awesome. Wait, can everyone hear me? Cool. Okay, thanks. So someone remarked to me that this is very much a philosopher's question. So I'm going to give you a very much a philosopher's talk and answer neither yes nor no. So what I'm going to be doing is I'm going to be largely agnostic about whether they do or do not, language models do or do not have communicative intention. What I'm going to be doing is doing something very negative, which is I'm going to say much of the negative answers we've gotten to the question, which is that they do not have communicative intention, are really bad arguments. We probably should start thinking about other more interesting social technical questions, but we'll see what I mean in a moment. Okay, so what I'm going to be doing is I'm going to be characterizing what I call the CI argument, which is the communicative intention argument, which is essentially the argument that says that language models don't have genuine linguistic competence because they lack communicative intention. And then I'm going to make a very brief remark about the sort of Gricean assumptions in the background. And then I'm going to raise 3 considerations against this argument. Okay, first, so there's been a lot said about communicative intention recently. And so the argument is a sort of a standard for in comparative approaches in philosophy of AI, where people say, for instance, AlexNet doesn't really see, AlphaZero doesn't really play chess. What do these readies mean? Cameron has argued that they don't have really empirical content. The attempt here is to give empirical content to a claim such as language models, sort of transformer models, for instance. I'm going to be talking mostly about transformers, do not have genuine linguistic competence because the empirical content here is to say that they do not have communicative intention, try to say what communicative intention is, why they lack it, why humans have it, and why that leads to that conclusion. A very famous example of the argument from communicative intention is Bender and Kohler's argument, which I guess a lot of people know about. Mary Shanahan's recent paper also argues something similar, talks about communicative intention and its role in linguistic competence. Some philosophers, also like Carlos Montemayor, also argue the same thing. So there's just as much to do about communicative intention. This is a passage from the Stochastic Parrots paper, which also makes a similar claim. The other claims thrown in, which I think are important, I'm not going to go through the passage. Every time I timed this, it was like 17 minutes. So I'm going to skip the thing. So as things stand, a lot of the arguments are sort of ambiguous. It's not really clear what the general philosophical argument is, and possibly they're just many communicative intention arguments, trying to say different things, but all appealing to the same notion, communicative intention. But there's often enough in each of these arguments to suggest that what's in the background is sort of this strong Gricean assumption about the nature of language. So I'm not going to go over all the details of the Gricean assumption, but essentially it's the assumption that leads to thinking that if you're genuine and linguistically competent, you should be able to attribute very high orders of meta representation. You should possess high orders of meta-representational capacity, because what linguistic competence involves essentially is trying to mind read other people, and sometimes so on the general Gryson schema, what you need to do is, as a hearer, not only recognize what the person is saying, but recognize that the person intends you to recognize that they want. So they're just high orders of meta-representational capacity involved. So there's a strong Gryson assumption, I think, in a lot of the statements of the CI argument. I'm not going to say much about it, but if my argument essentially here is that if, in fact, the argument rests on the strong Gryson assumption, it fails for well-known reasons. I'm not going to go to them, but we can talk about them during Q&A. There are a lot of good reasons why they fail. I will fight anyone on any street corner about this. The strong Gryson assumption is false. But I think you can still, the CI argument can still get off the ground with sort of an attenuated Grycianism. I'm not going to say much about that. I'm going to leave all of that in the background for a bit. All you need to know right now is what's up here. So this brings us to, I think, what's the central argument of CI arguments, which is an argument that language models lack communicative intention. And why should we think that? So a principal argument for this is that, well, the language models, especially transformers, just have the wrong kind of mechanisms. They don't have the proper mechanisms to encode communicative intentions. More directly, some people, like Mary Shanahan in his recent paper, says something like this: it doesn't matter what internal mechanism it uses, a sequence predictor is not in itself the kind of thing that could even in principle have communicative intent, and simply embedding it in the dialogue management system will not help. Okay, so I'm going to be addressing this argument. So, but first, so to see what the motivation behind this sort of argument is, right? So consider going through all the layers of a transformer and try to figure out where, what feature of the transformer might plausibly encode intentions. Right. So the proponent of the argument might say, look, we know the input embedding and the position embedding together provide us these sort of position-wise vectors of the natural language sequence. That doesn't seem to have anything to do with communicative intention. The multi-head attention provides us sort of these relevance representations of which part of the token are important to figuring out what the whole sentence means. And the feed-forward network takes a sort of a soft max of this output. And so whatever it is, it's a function of this output, and it couldn't really encode intention. So the argument goes something like, where in this process could intentions be encoded? And before we start trying to answer that question, we should query what the empirical situations in the case of humans, because I think without a sort of a empirical clarification, it's not really clear what people are talking about when they're talking about communicative intention. There could be a lot going on over there. So what is it in human cognition that, or what sort of mechanism is it that people are interested in when they're looking for these sorts of mechanisms? The answer is that no one knows. And in fact, if you, for instance, are instrumentalists of some variety, or if you're sort of an eliminativist of some variety, you don't actually think you should be looking for such a mechanism at all. There's no mechanism to be looking for. The problem is that while communicative intentions are pretty useful in psychological theorizing, the use in psychological theorizing is largely instrumental. So there's no direct cognitive scientific evidence for the psychological reality of communicative intentions. Instead, what we have in some well-evidenced models of like language comprehension and language production, like the lemma model, which is a model that tries to explain, for instance, how you utter the cat is on the mat by showing how you select the phonosyntactic elements of that utterance and then produce it. In models like that, what we have is that communicative intention is just a boundary condition for the mechanism. It tells you what the mechanism is trying to produce, but there's nothing over and above the end goal of the mechanism that is communicative intention. So it's a boundary condition rather than anything, any specific mechanism. And also in general, surveys of the literature suggest that there's this good empirical reason to be skeptical of the psychological reality of communicative intentions. So we end up in a sort of a situation of empirical parity, right? If humans are legitimately thought to possess communicative intention, even though we have no mechanistic hooks on which to hang those intention attributions, then there's really no good reason to think that we might not also be able to attribute communicative intentions to machines. even if you can't find any such hooks, but we in fact can find some of them. In some older language models, we find that there are features that are meant to explicitly represent intentions. So for instance, you might see this in partially observable Markov decision process dialogue systems, in which is a belief state representation, which is supposed to track which of a variety of actions a user wants to take. You can see this in other older dialogue systems, which are well elaborated modular pipelines. So in fact, in many task-oriented chatbots, you actually want to explicitly represent which set of possible actions that a user wants to take. For instance, if you have a chatbot that recommends restaurants, gives you restaurant ratings, and makes reservations, you need to know which of those three tasks the user wants to trigger. And it's really useful to be able to represent this. There are many ways of doing this. You can use the sort of like a partially observed Markov decision process, as I just showed. You can do stuff more that are closer to some of the older sort of ELIZA type chatbots, sort of semantic search. So in all of these cases, the sort of the representation of the possible action of the user wants to trigger is used to guide language generation model downstream. And this, I think, is super important because going back to the point about empirical parity, you might make the argument that, look, the reason why we think there are communicative intentions in human beings is because we make sense of particular actions that they take in terms of it. I think that sort of control view of the use of communicative intention gives us at least some similar empirical parity argument here to say that, well, look, if these representations are guiding the actions, the actions of the chatbot, then we are pretty much in a similar situation as in the case of humans, right? Of course, many state-of-the-art language models based on transformer architectures do not use any well-elaborated pipeline like this. And so you might think, look, this is just a bait and switch. I was going to talk about transformers mostly, and now I'm just talking about older natural language processing systems which have these belief state tracking modules. I think this might be a bit too hasty. So consider a parallel question, right? Whether, for instance, language models distinctly represent various salient syntactic and semantic features. We know that humans do this. So if you're doing a sort of cognitive comparison, you want to make sure that the language model you're looking at does something similar. Classical NLP systems would have lent themselves possibly to such comparison because they have, for instance, part of speech tagging components. So they're tracking some salient syntactic semantic features. They also have parts for resolving co-reference. So these well-elaborated modules in the systems that helps you figure out in much the same way human cognition does what the relevant syntactic and semantic features. And until recent work, it might have seen that transformers, if you'd run the same sort of argument, you might have thought, well, transformers don't do anything of that sort. They don't represent any sort of salient syntactic and semantic features. We know that's false now. We know that, in fact, that appropriate probes can disentangle representational features in transformers, which recapitulate the classic NLP pipeline, complete with distinct hierarchical representational sensitivity to parts of speech, semantic roles, co-reference, etc. So the conclusion here is that if this sort of argument of running through the system and trying to figure out where something might be encoded, it's a very dubious argument, and we should not rely on it. Obviously, you might say, look, these features in the analogical case are categorically different of a different kind. Look, speech, semantic role, co-reference can be structurally derived from the corpus. After all, they are intra-linguistic features, not extra-linguistic features. However, communicative intention doesn't seem to be that sort of thing. But I might talk about this more in the Q&A, but there's evidence to suggest that attribution of intention, including self-attribution, is dependent on linguistic mastery, which suggests that semantics of intentional terms are significant from the ontogeny of communicative intention. And also another point, which I think is usually lost in the philosophical debates on this issue, is that there are parts of the fine-tuning process in training language models, which might have a dialogical context similar to the ones from which human beings learn some of these the intentional capacities, right? So reinforcement learning with human feedback, for instance, I think might encode some of these dialogical properties. And as we saw earlier, sort of cognate version of this wrong kind of mechanism argument is the argument that basically there's just, no matter what you do, a sequence predictor is just not the right sort of thing for communicative intention. But there is in fact evidence that human language processing evinces significant sequence prediction features. I will not go into detail about these studies, but we can talk about it later. But this is a famous study by Curtis and Hilliard, in which they presented sentences of that kind to people, and the N400 potentials suggest that there's that human semantic processing is attuned to the most probable continuation of linguistic sequences. There's a significant inflection for unusual sentences like you took a sip from the transmitter versus you took a sip from the waterfall. I don't know why they think that's less weird than transmitter. I don't know who drinks from a waterfall. But yeah, and it's also something interesting is that the amplitude of the signal is inversely correlated with the close probability, which is the likelihood given by, so the probability that a human being will suggest that part of the sentence is a continuation, which is very akin to the perplexity. So semantic processing in humans is attuned to the most probable continuation of linguistic competences. We also know that syntactic capacities are also attuned to these. There's also like further evidence from conversation analysis for that previous claim. If you want, we can talk about it later. So we know that syntactic capacities are also attuned to this sort of predictive features. And a good famous study by on that point is Christensen and colleagues study, in which they show, using also similar devices as the last study, that the same sort of brain areas that are involved in generic syntactic processing, generic sequential learning, are also involved in syntactic understanding. So there's sort of two, so between its role in semantic language processing and its role in syntactic processing, it's clear that sequence prediction plays a significant role in human linguistic competence. However, it's like there are two sort of conclusions we can draw. There's sort of a cautious conclusion, which is that there's really no good reason to think that sequence learning could not be the basis of genuine linguistic competence. At best, the evidence is just completely inconclusive. There's a more tendentious claim, which is that at worst, the evidence suggests that sequence learning is at the heart of human linguistic competence. And since, for the sake of argument, human linguistic competence is exemplary of communicative intention, sequence prediction could be exactly the sort of thing that Shanahan thinks it can't be. But this requires us to show that sequential learning in humans and language models fulfill the same sort of functional roles, which is the next part of my project. I was very optimistic that it was the same sort of thing. I'm not so optimistic now. So even though I had in the beginning said I was agnostic, you can begin to suspect my own position on the matter. So in summary, I skipped the Gricean part, but in summary, if the strong Gricean assumption that seems to lie at the heart of a lot of the CI arguments is right, it won't get off the ground because we know it's false for many anthropological, psychological, evolutionary reasons. Even if you have like an attenuated Gricean assumption, it would still not be very convincing because of some of the reasons I've just shown: empirical parity, there might be plausible mechanisms in language models, encoding, communicative intention after all, and there might be more work for sequence learning than CI arguments suspect. Okay, good. That's, I think that, yes, that is in fact it.
Okay, 16 minutes, 45 seconds. Very good.
I cut down the time.
I wonder if your point about communicative intentions really applies to really all intentions.
Right.
So, you know, it's people have observed that the only time we have intentions as like separate states is when there's a process of deliberation that issues in like something like an explicit intention. But there are intentions in some kind of more dispositional way for all, you know, for anything we do really, in the sense that you would agree that they're done intentionally. And the same thing, isn't the same thing true for communicative intentions?
Yeah, so one of those papers I cited earlier by Mazzone and Campisi, which is a sort of a survey of the literature on intention in general. So the paper is actually surveys the literature on intention in general, and then makes a conclusion to communicative intention in particular. And it suggests that we have reason to be skeptical of intentions in general. My own position in this matter is that, in fact, there are communicative intentions, there are intentions for a lot of other things, but they do not arise where I think a lot of philosophers have tended to locate them, which is sort of like the sort of these internal representations of intentions. I think intentions arise in the context of social behavior. They help us make sense of behavior in a social context. That's where you should locate intentions. And I'm happy to let go of the assumption that you can find some sort of internal representations of intentions, just as long as I think it makes sense to use it to make sense of social action.
Think about this in like an empirical way. Shouldn't there be a way, if there is the intention there, to recover it from the utterances? And shouldn't there be kind of consistent intention over some amount of time? And, you know, these models seem to not have consistency in that way, that they're not, you know, trying to argue for a point or anything like that.
So one of my advisors, Edward, I went and spoke to him, and one of his main points to me was like, look, I know I have intentions because I could be wrong about stuff I intended. For instance, I might say something and realize, oh, I was wrong about what I intended to say, something like that. You don't get a parallel like that in machines per se. As you mentioned, there's some reason to think they're not arguing for any particular point or anything of the sort. Something I failed to mention, which I think is really critical to the argument, is that you can make you can have a taxonomy of very different kinds of intentions. So there are intentions, for instance, if you make the statement, I would like a banana, right? The intention is for someone to give you a banana, or open the door, the intention is to open the door. I don't think language models that we have right now have any of those intentions, precisely because they're not embodied agents. However, there are certain kinds of intentions. These are sort of intentions that intend a illocutionary effect. There are certain intentions that intend an illocutionary effect. So I ask you, what's the capital of New York? Give me a response. I think legitimately you might be able to say that at least these systems might have at least some very, very limited range of intentions, part of which is to just answer questions. Its only intention might be to answer questions, whether accurately or not, I don't know, right? I think that if you're going to attribute intentions in that way, in fact, you might have to attribute like an even narrower intention than the intention to answer questions. It might be the intention to answer a very particular question. What is the continuation of this sort of sentence in the corpus, right? So it's an even narrow intention. My argument is not necessarily that language models have intentions, that possibly they do, but if they do, admittedly, it is a very narrow range of intentions relative to what humans have, right?
So my question is sort of on related to this. So as we've seen, like with the scaling up of the amount of parameters that we've trained language models on, they have new emergent capabilities. Do you think maybe that sort of as we sort of train these models with even more parameters and maybe new architectures, that they might have the capacity to be constrained in any type of kind of task, kind of behavior? Because if we look at something like GitHub Copilot, they just announced like a new programming assistant, even though it doesn't necessarily have like the anthropic sort of centric sort of understanding of what intention is or what doing a task is, it's still able to provide a complex syntactical structure that does some kind of action, some kind of task based on sort of whatever it was led to do, initially prompted by humans. So do you think sort of more complicated sort of understandings of other minds might sort of emerge in language models just due to that emergent scaling?
Right. So I think there's a recent paper on I'm going to start with the latter question first. So I think there's a recent paper which argues that sort of a theory of mind has emerged in language models, and then it goes on to test, I think, GPT 3.5 on sort of a standard false belief tasks, and then it does really well. And then people are like, yeah, we got an emergent theory of mind. Lieutenant Commander Data is right around the corner. But as it turns out, if you perturb the test just a bit, it completely fails. And I think that one of the really crucial things about it's like sort of these assessments of AI is just trying to figure out I think the more interesting question, rather than trying to figure out like whether they have these capacities, trying to figure out the range in which they can be successfully operated in these capacities. And as I was just saying to the last question, right, if you take aboard sort of my view, which you don't have to commit to because it's not part of this, then you should not even be trying to find intentions per se in the operation, in the mechanistic operation of the system. It's about, this is why at the beginning I said, I think the more interesting social technical questions is how is the system embedded in its social context? Machines are sort of things that could ever be embedded in the way that leads us to attribute intentions to them. It seems like the context in which we meet machines most of the time is not that sort of context. Also seems like there's a sort of like dependency in the way in the very fact that machines are engineered objects on sort of human intentional capacities, which also raises questions about whether they could ever be embedded in our social context in a way humans are embedded, right? So I think they're more interesting social technical questions. Part of my project is to say enough with some of these questions already. They're much more interesting questions. So yeah.
Okay, one more quick question.
Thanks for the talk, super interesting. Just want to ask, to what extent do you think the recent introduction of RLHF as part of the training process of the most advanced current models changes the game entirely in terms of this argument about communicative intent? Do you think that the broad landscape of the dialectic for and against is similar with the incorporation of RLHF, or do you think it becomes a very different kind of question?
Right. So yeah. So as I was hinting earlier, right, I think that a lot of the debates just miss out on a lot of what's interesting about how these systems are trained, right? Because typically what you have is well, I think at least typically what people have in mind is this: there's a corpus, and you go and learn the linguistic dependencies in the corpus, and that's the end of it, right? But what you get with RLH have other fine-tuning mechanisms like that is a context that seems a bit more dialogic than what we've typically seen. So one of the ways in which at least we think that humans learn sort of the semantics of intentional terms and how they learn to mind read is that they're embedded in a social context in which they observe dialogues, right? They observe how people talk, they observe how people react to them when they talk. I have not done any like serious work on this to figure out whether in fact the sort of dialogic context you get in some of these fine-tuning mechanisms are entirely similar to what you get in these human contexts, which is, I think, one of the more interesting questions, looking at some of these mechanisms and seeing whether they're similar enough to some of the very social mechanisms which we think underlie human capacities to attribute intentions. Right. I don't know if that answers your question, but I think it does change the philosophical landscape quite a bit. I think people should pay more attention to it.
Okay, thank you.
Thanks.
Okay, next up we have Patrick Butlin from Oxford with a function, content, and understanding in large language models.
Okay, hi everyone. So I'm going to be talking about a topic which we've heard lots about already, which is the topic of whether language models can understand, and more specifically, or slightly more specifically anyway, I'm going to be talking about whether language models can understand typical human utterances. The reason for making that clarification is that there's not just one phenomenon of understanding, there's not just one question that we can ask about whether a system understands things. So I'm going to be thinking about issues like whether a language model could understand a particular human, particular sentence which might be uttered by a human, like the sentence "volcanoes erupt." That seems to me to be a different question from, although of course not unrelated, from the question of whether a language model could understand why volcanoes erupt, for example. And this is a topic which I've written about before in this paper called Sharing Our Concepts with Machines, which I wrote a few years ago. It's published 2 years ago. I argued for two claims on this topic. The first one was that the lack of perception of the human environment, which is a feature of language models, doesn't prevent them from understanding human utterances. So I would have been on the no side of the debate on Friday night. I don't think that sensory grounding is necessary for understanding of this kind. But I'm not going to say anything more about that claim today. Instead, I'm going to concentrate on a second claim which I made in this paper, which is that the fact that language models lack functions or tasks concerning the human environment does prevent them from understanding human utterances. So I made an argument to that effect. I'll call it the function argument. And what I want to tell you today is that I take it back. I recant that argument. So it's not that I now believe the opposite of the conclusion, it's that I now no longer believe that the argument's correct. Okay, so I'm going to start by explaining the argument, of course, and then I'll tell you some of the things which I think are less than entirely convincing about it. Okay, so this is the central kind of theoretical claim of the function argument. It's that understanding human utterances requires functions or tasks concerning the human environment. When I talk about the human environment or the world, what I'm referring to, of course, is the kinds of things that typical human utterances are about, like volcanoes or chairs or cats or love or anger. Okay, so there's kind of three premises which contribute to this central theoretical claim. The first premise is that understanding an utterance involves forming a representation with the same content. So here the thought is something like, if you say to me, hey, Patrick, volcanoes erupt, then in order for me to understand what you've said to me, I have to have the thoughts, volcanoes erupt, prompted by what you've said. And I'm assuming a representational way of thinking about thoughts. So for me to have that thought, I have to form a representation with the content, volcanoes erupt. I'm not saying that I have to come to believe that volcanoes erupt, I just have to entertain that idea. But the point is, if you say to me volcanoes erupt, then that's going to work. I am going to form a representation with that content. If you say something to me in a language other than English, then it's very unlikely that I'm going to form a representation with the right content. The second premise is that content depends on function, and this is the central claim of teleosemantics, which is a philosophical theory of representation, which you've already heard things about this weekend. So I'm only going to talk about teleosemantics in a kind of very sketchy, high-level way. But here's a kind of slightly more detailed claim about how representational content works according to a teleosemantic picture. So the claim is that for representation to have a particular descriptive content, like the content volcanoes erupt, then it must have the function of carrying the information that volcanoes erupt. So it's not enough that the occurrence of the representation carries the information in question. Instead, that representation has to be used by the system. And it's the use of that information by the system that makes it the case that this thing, the representation, has the function of carrying that information. And then the third premise which contributes to this theoretical claim is that a system will only use information concerning the human environment to perform whatever task it has if it has a functional task which actually concerns that environment. Now, of course, to go from that theoretical claim to a claim about language models, I need to say something about the functions or tasks of language models. And so in making this argument, I just took the very widespread view that the task of a language model is what it's trained to do. So it's next token or next word prediction. And I would characterize this as a purely linguistic task. It's a task in which success depends on success is measured by standards which arise from facts about language itself. And so in order to achieve success, a system is going to rely on its states, its weights or its activations carrying information about language, not about the human environment. And so just to be as clear as possible that this is a distinct argument from the century grounding argument concerning understanding, I think it's useful to contrast the case of a language model with a case like a fictional text-only medical diagnosis chatbot. So we can imagine a bot which has been trained only on text and which interacts with users only through text, but the function of which is to identify the condition that the person that the bot's interacting with is suffering from. In this case, the function does concern the human environment. What it is for the chatbot to succeed is for it to, I don't know, at the end of the dialogue, output a form of words which like truly describes some facts about the human themselves. And so it looks like if we're thinking about what kind of information that system states are going to have to carry in order for it to succeed in performing this task, that's going to be information about the patient's symptoms, for instance. Okay, I have 3 objections in mind to the function argument, but today, for reasons of time, I'm only going to talk about 2 of them. So the first objection, I mean, they're both very extremely simple objections. The first objection is just that these days language models are fine-tuned for further tasks beyond next token prediction. So for instance, one objective that you might have in fine-tuning a language model is to get it to give correct answers to factual questions. So a language model which has been fine-tuned in that way, you might think, is no longer performing only a purely linguistic task, because getting the right answer to a factual question is a matter of your answers correspondence with how things actually are in the world. Okay, I'm not going to say anything further about that objection yet. I'm going to come back to it in a moment. First, I'm going to mention the second objection. So the second objection is that in principle, it seems as though information about the world, the human environment, could be useful even for performing purely linguistic tasks. If you want to produce an output which is likely utterance in human language, then knowing about the human environment, knowing what humans believe, is very useful information, it seems. So yeah, we can imagine that in principle, language models might represent facts about the human environment, even though, even in cases in which they're performing only purely linguistic tasks. And in particular, there are some kind of further features of the discourse about language models at the moment, or pieces of evidence which are relevant to this issue, which kind of push us towards the thought that language models might be using representations which concern the human environment. So one is that interpretability research sometimes posits representations with worldly content. And another reason is that there are some aspects of language model performance which it kind of seems rather difficult to explain if they're not representing facts about the human environment. So here's one example. It doesn't really matter very much for my purposes how compelling an example it is. But this is from the recent Sparks of AGI paper about GPT-4, and we've seen this image already this weekend. This is output produced by GPT-4 when it's asked to draw a picture of a unicorn using this LaTeX image drawing language called TIX. And you might think, well, surely GPT-4 represents that unicorns have 4 legs, and that's part of the explanation of how it's able to do this. Okay, now I'm going to talk about both objection 1 and objection 2, because I want to say more or less the same thing about both of those two objections. So here's the kind of picture which is painted by the first objection that I mentioned. So suppose you've got, on one hand, a pre-trained language model, and on the other hand, a fine-tuned language model, which has been fine-tuned to produce the correct answers to questions. Then when you provide the same input to those two models, the input, what's the capital of Estonia? The thought is they're performing different tasks, and because they're performing these different tasks, they're using different pieces of information in order to produce their outputs, even though they might produce the same output. So in the case of the pre-trained language model, the task, according to this picture, is to provide a likely continuation of the text. And so it's using some information about the language, something of the form. Tallinn is a relatively common continuation of the string, what's the capital of Estonia? On the other hand, in the case of the fine-tuned language model, the task is to answer the question correctly. And so the information which is being used in order to perform that task is the information that Tallinn's the capital of Estonia. Now, I think we shouldn't be confident that this is the right picture to have in mind when we're thinking about representational content in these two contexts. And the reason is that these two pieces of information are, of course, extremely closely related. It's because Tallinn's the capital of Estonia that we say things that we do, the things that we do about the capital of Estonia. So in general, features of a model which carry one of these pieces of information are also going to carry the other piece of information. So the information that Tallinn is the capital of Estonia is in some sense available to the pre-trained model, and the information about the language is available to the fine-tuned model. And furthermore, it seems that either piece of information could be used to perform either task. So you don't have to tell a particularly complicated story in order to explain why the pre-trained model produces the output Tallinn in terms of the information that Tallinn is the capital of Estonia, and equally you don't have to tell a complicated story to explain the fine-tuned language model's performance in terms of information about words. So where that seems to leave us is that, well, there's a rebuttal available to the original objection to the argument, which is that even in the fine-tuned case, it's possible in principle that the language model is only representing information about language. But it cuts both ways, because it's also the case that even in the pre-trained case, there's a story available to be told about how information about the human environment could be being used. And I think we can say these kinds of things about the unicorn case as well. So it's possible that GPT-4 is using the information that unicorns have 4 legs in order to perform this task. But I also think it's possible in principle that GPT-4 could be relying on some relatively complicated fact about relationships between words, like the words unicorn and 4 and legs, and maybe some shape words, and maybe some bits of TIX code in order to perform this task. I think in principle there's going to be a kind of purely linguistic interpretation of the representation that's being used to perform this task as well. So we've got a problem. It seems certain that language model states typically carry information both about the world and about language. Information of either kind is typically useful either for performing linguistic tasks or performing tasks which are not purely linguistic. So we don't know which kinds of information language models are using, and therefore what the content of their representations are, even if we know what tasks they perform. And the philosophers in the audience will have long since recognized that this is a completely familiar problem. This is the indeterminacy problem for teleosemantics. It's the problem that in any case in which a state of the system is carrying information which is useful to that system, that state of the system is also going to be carrying a whole load of other information as well about facts which are correlated with the fact of interest, and that stories are going to be available to be told about how those other related pieces of information could be used to perform the task in question. Now, the reason that this problem arises is that the theory is kind of relatively impoverished. It doesn't tell us, in at least in the form that I've given so far, in very much detail about how information is determined by about how representational content is determined by function. So it can be solved by defending a richer theory of content. But then, of course, there are open questions about what that richer theory should look like. Anyway, the upshot of this is that when I first wrote about this topic, I expected that the question of language model understanding could be settled by appeal to quite broad philosophical principles. I think that might still be true, but I don't think they'll be the principles that I had in mind. I think that much more detailed analysis is needed to clarify representational content in language models, and we've seen some of that, some attempts in that direction earlier this weekend. Thanks very much.
Wondering about one other objection to the function argument, very obvious one. Saying that the task of language models is to predict the next word is a lot like saying the function of human beings is to leave enough offspring around or enough copies of your genes. Of course, in the case of human beings, we know there are a million instrumental functions that we have, talking and walking and breathing and so on, that enable that large function. That's maybe they're functions of us, maybe they're functions of subsystems. So I think that likewise, in the case of language models, there's all kinds of instrumental functions that language models could well develop, very sophisticated capacities in order to enable this overall function of predicting the next word. And those seem like very natural things to play into a teleosemantic theory.
Yeah, I'm not sure that, I mean, I suspect that there are other objections to the argument, but I'm not sure that I immediately find that one compelling. Because I mean, with one reason why we think of next word prediction as being the function of language models is that the form that language models takes is explained by the feedback that they get as they kind of succeed or fail in predicting the next word. And the form that human minds take is explained not just by evolutionary processes, but also by processes of learning within our lives. But those processes of learning within our lives are also kind of thoroughly world-directed, world-involving. Whereas if you kind of break down the kinds of things that language models do, which cause them to receive feedback, which change their form, they're just less general purely linguistic tasks. So there's like next word prediction in general, but there's also next word prediction in one kind of context and like next word prediction in another kind of context. It seems like we still get a purely linguistic picture if we try to kind of break down the tasks that language models are doing in contrast to the world-involving picture with humans.
As you know, I'm sympathetic to wanting to do a teleosemantic. I thought Dave was going to go in the other direction. I mean, it's just kind of an illustration of indeterminacy of function, but you might say the task of even the pre-trained models is to produce convincing text, and the next word prediction is just a means to that. You know, what it's selected for, if you think of this sort of analogy of the evolutionary environment, what it's selected for is, does it work to produce Turing level convincing text or something like that? And so you might say that's what the task is. That's what the function is, right?
I don't understand that selection, because in the process of self-supervised learning, there's no assessment is made of whether text is convincing or not. The model gets kind of feature preserving feedback if the word that it predicts is the one which actually was in the gap, and it gets feature modifying feedback if the word it predicts isn't the one that was in the gap. That's why I would kind of be kind of relatively confident that next token prediction is the right way to think about the function.
So I wanted to ask you to clarify what exactly you're renouncing. So when you said at the beginning that lack of function or task concerning their environment prevents language models from understanding, I was like, yeah, that seems absolutely right. And you're like, I renounce this. But then it seems like most of the rest of the argument had to do with more like how the claim doesn't apply because maybe their tasks or functions do involve the environment. So I guess I was wondering, like, do you actually renounce that principle, or is it just the application of it to current LLMs that seems like not to work?
Yeah, sure. So the first objection, doesn't seem to be evidence against the principle because it's a case where the functional task is different. The second objection, which is like a much woollier objection, nonetheless is a thought to the effect like maybe that principle isn't right, that even though the functions or tasks are purely linguistic, it could be that the representational content is world involving. I'm uncertain both about the kind of claim about the relationship between the function and the content, but then the first objection, of course, is like about what we should say about language models and understanding, kind of independently of claims about their function.
One more.
Yeah, I just had a question about the distinction between like the two types of tasks between the pre-trained and the fine-tuned LLMs. So it seemed to me like that there isn't necessarily too much of a difference between the two types of tasks, where with like the pre-trained LLM and it's just drawing connections between things, it seems like it's just a broader class of actually like knowing the information, or it's like knowing the information is a subset of drawing representations between things that are just generally associated with like unicorns. Is that like the framing that you were going for, or do you think that they're distinct and separate things? Was that clear?
I'm not totally sure that I understood the question, but let me try answering it. So my thought is that next word prediction is a purely linguistic task, because what makes a particular output correct when a language model is performing that task is facts about the statistics of human language. Whereas correctly answering questions is not a purely linguistic task, because what makes an output correct when performing that task is whether the answer corresponds to the facts about the world, facts which are not about language. Is that, yeah?
Okay, thank you very much.
Thanks.
Okay, and our final talk is by Philippe Verreau-Julien of Eindhoven, who will speak about 5 lessons large language models teach us about understanding.
Okay. Yeah, in fact, we're down to 4 lessons. In fact, I changed the title in the meantime, and then yeah, it seems it didn't follow the link. But anyway, so if you want to, I mean, we're gonna see it now, I guess, quickly. Otherwise, you can access the presentation on the link or the QR code. You can leave comments also to tell me what I'm obviously wrong about something. And also, I'd forgotten to change the title when I sent it to Rafael, because I didn't know whether I wanted to commit to 5 or less lessons. Anyhow, here we go. Yeah, first of all, because I mean, also it's the last talk, I just want to also thank again the organizers, staff, sponsors, everyone for this fantastic conference. I learned a lot, met a lot of great people, had nice conversation. So it's all fantastic. Do large language models understand? Well, I mean, we already heard a lot about, I mean, this topic so far in the conference. There's a lot of debate in the literature. Melanie Mitchell was saying, so understanding these situations we experience, being able to grasp their meaning. Today's AI systems, I mean, lack that, they lack of human-like understanding. The Stochastic Spirits paper also, though there's no actual language understanding is taking place in the ML-driven approaches. Browning and LeCun, so in the Noema magazine, they were also talking of LLM's understanding of language being impressive, but shallow. And yeah, if you also probe or survey, so that's from a recent survey of NLP researchers, where they were basically split in the middle over whether LLMs could or not understand language. I think the could was also interesting in there. So because it was not like can, maybe it's could in the future. So I think it was a bit ambiguous to me whether they understood that, they believe that they were already understanding or not. And yeah, in parallel to this, I mean, the last year and a half has been crazy. The models are being increasingly powerful. The capabilities increase all the time, and I think a lot of people, I mean myself included, are updating their evidence and credence towards maybe some of the stuff we were holding before. So this is again from the GPS from OpenAI. So we've seen, I guess everyone has seen this this table with impressive improvements in capabilities on many tests that we actually use to assess whether humans understand. And there's really a big jump in many of these categories. And even some people started to talk about sparks of general intelligence. And so the project I'm interested in to talk today about is whether, so examining, probing, studying the large language models contributes to debates about understanding in natural language processing and philosophy. So in fact, so before I had 2 lessons, I taught for NLP and 3 for philosophy. And now, so we're down to 1 for NLP and 3 for philosophy. And I think here my kind of project, in fact, is really to look at how the large language models can inform some of the debates about understanding in philosophy. And in fact, maybe I should also say, so contrary to Patrick before, so he was not interested in why volcanoes erupt. This is what I'm interested in. So why volcanoes erupt. So so I'm here really some philosophy of science, also doing some epistemology, but really so the kind of perspective I have on this is really from explanatory understanding, objectual understanding, understanding of phenomena, understanding of maybe the empirical world. And now the large language models are not understand. So lesson 1, understanding comes in degrees. And I have a bit mixed feelings about this because it seems it's something that somehow we acknowledge, but at the same time, I mean, we don't. So we've seen some of these quotes before, sometimes talking of like no understanding at all. Sometimes, oh yeah, shallow understanding. So maybe we would suggest there is some understanding, but there's really this kind of in the debates, so claims about whether LLMs understand are really quite often categorical. So either they understand or they don't. But from the philosophy of explanatory understanding, well, it's really a platitude that understanding is a graded notion. I mean, some people can understand more than other, maybe a given phenomenon. Someone can have a better explanation of something, can have a more detailed, maybe grasp over the phenomenon. And I think this mirrors very well what's happening also with the language models, where we're really seeing, well, incremental or very incremental progress on various metrics or proxies of understanding. And I think it really suggests that, I mean, not suggest, but I think that one lesson there from insights for both the behavior of the large language models and also from philosophy is that when no understanding is also different than shallow understanding. Okay, and so one way of thinking about this, the framework from Khalifa is work on explanation. So it's adapt from this. So you can think of understanding and being maybe in a state of proto-understanding where we have maybe something that looks like understanding, but it's not quite right there. And then at some point we pass threshold, and then we have minimal understanding, and then that understanding can improve. It can be a situation of improved understanding. Some people even talk of ideal understanding to try to come up with then maybe notions of graded understanding. But I think that's a useful way of thinking about what the large language models do. So maybe they don't, maybe they never pass the threshold for minimal understanding. But I think these two questions, I think, would help maybe frame a bit better the debate over their understanding. So what's the threshold for minimal understanding? But also, how do we assess the degrees of understanding? And yeah, I don't have very concrete suggestions for you. And I suspect, in fact, that there will be, I think, productive back and forth between advances, maybe in NLP and AI, and also philosophy on that in that respect. Yes, so this is, I'm not going to talk about this. So yeah, lesson 3, grasping matters. And in fact, I think that mirrors, so I think that's the area where we're, the linguistic meaning or the understanding of language proper, I think comes back a bit. So all accounts of understanding require some basic set of cognitive abilities, considering and comparing explanations, counterfactual reasoning, representation manipulation, cognitive control, grasping. So let's just call them grasping. Some people have a very specific notion of grasping, but let's call them grasping. Now, do large language models grasp anything? Yes, apparently. So GPT-4 grasp the theory of evolution by natural selection. And well, I mean, on the face of it, I mean, you read this and it's, yeah, it's saying a lot of relevant true things about the theory of natural selection. But then I pressed a bit GPT-4, do you really grasp it? And I think, in fact, it raised an interesting interesting questions about the nature of grasping and what kind of maybe philosophers, what kind of questions maybe philosophers should a bit focus more in the future. So as an AI language model, I don't have personal experiences or emotions, but I can understand and explain concepts like the theory of evolution by natural selection. And so I think there are two relevant debates here to that question. So what are really the abilities that are constitutive of grasping? So there are, I mean, different theories, but I think perhaps the bit more pressing question in the case of large language models is whether grasping is merely phenomenal or inferential. And this is something that, definitely something that in my work, and I think a lot of philosophers of explanatory understanding have not paid super close attention to. I think it's just something that a lot of people just, I mean, took for granted. So a lot of philosophers of understanding, so they mostly discuss some particular abilities that are necessary for understanding, and they tend to endorse the inferential account. But in that case, it seems that if we require consciousness for grasping, then maybe we need large language models to be conscious to grasp and understand anything. So it seems there maybe we need an answer, but to that question, and preferably maybe an answer also that would be applicable to both humans and AI. So grasping and its relationship to understanding may be crucial to understand whether LLMs understand. Lesson 4, inferential abilities aren't the end of the story. So I think, philosophers, we love inferences. We see inferences everywhere. And so so if you survey a bit, I mean, the literature, the abilities that philosophers tend to be considerative of understanding are almost always inferential. So things like counterfactual reasoning, especially the kind of Woodwardian counterfactual reasoning. So if you have a theory of explanation that tells you that having counterfactual information provides understanding, then it seems it's just a silver bullet to understanding. And if you can do what if inferences, then you understand. But things also like representation manipulation and even cognitive control, I guess, I mean, we could have maybe different interpretations of this, although I think the most plausible one is really inferential. And the thing is that, well, large language models are just very good at their inferences, or at least increasingly be good. So this is Alison Hill's account of cognitive control. So we're not going to go into the detail of it, but you can see, so there are like different conditions for cognitive control. So following some explanation of YP, and I think so that's closer to linguistic competence and grasping, but also just explain YP in your own words, draw the conclusion that P from the information that Q, draw the conclusion that P prime from the information that Q prime, where so they're similar in similar piece of information, but not exactly similar. Given the information that P gave the right explanation Q, or given the information that P prime gave the right explanation Q. And well, just again, give a very quick example of explain YP in your own words. So this is why Napoleon was a great military leader. So that's the example that she discusses in the paper. And yeah, we are the model is giving us a lot of reasons for why Napoleon was a great military leader. So yeah, if you look at the presentation, so you can see how maybe it's answering to the different conditions, and it's doing quite well, I would say. So it seems it has cognitive control if we're just using those conditions. But then I think here, philosophers can maybe a bit more aware of maybe some of these other abilities that seem to be important in the context of large language models and maybe AI systems, I mean, more generally. So here, maybe I'm not up to date with the state of the art, but yeah, I think there's at least until recently, there was not consensus, but yeah, view that, well, these AI systems are not as good with other abilities, such as maybe abstraction or analogy. And this is just something that philosophers are not paying so much attention to, at least in the philosophy of understanding. And so I think, again, so looking at what's happening in with the large language models, I think suggests that philosophers maybe should pay more attention to this and maybe also integrate these kind of other abilities into theories of understanding. Now, lesson 5, understanding may not be compatible with lack of justification or falsehood. And this is, yeah, one, I think, aspect that I find, particularly interesting. According to some accounts of understanding can be non-factive. So the idea there is that falsehood may afford understanding. One common justification for this is the case of highly idealized models. So models, they misrepresent realities in various ways, but they still seem to deliver epistemic goods. And then our epistemic goods are somewhat contaminated by falsehood, and then it would become, non-factive. Other people defend that understanding doesn't require justification at all. So maybe just grasping the truth is sufficient, or accepting the truth is sufficient. So there's a clear disconnect with justification. But yeah, large language models are very good at mimicry, the stochastic parrots, in Parlement French, they can be even bullshitters, some people say. So the connection between truth, justification, and the output of large language models seems, tenuous at best. And well, do LLMs that rely on falsehoods understand? That's, not obvious, at least. And I think the justification that comes from usually, so the success of science and idealized models. So if you look at, if you justify your account of non-factive understanding on the basis of highly successful models in physics, well, it seems there's a strong disanalogy here that can be made. Are large language models, justified in their output? So is there appropriate justification, or the process is reliable? Well, in fact, we just don't know. So maybe I think we would need much more information, maybe about the training and exactly so the construction, the architecture, maybe probing them. So maybe something like also interpretability. But I think this is something that's quite important if we want to assess whether the models are understanding or not. But also, I think, in general, also we want maybe large language models to understand for the right reasons. And I also believe that this puts pressure on accounts of understanding that believe that maybe it's non-factive, or that the justification is not necessary. So how could large language models be indifferent to justification or truth, yet understand? And one reason why I think this is also especially important is that justification and truth is really crucial for ethical issues raised by AI. So we want maybe AI to not indeed to be justified in their output. So just, I mean, quick final remarks. So I think this is really a fascinating and super interesting areas where NLP and philosophy can, I mean, fruitfully engage with each other. So again, so as a philosopher of science, I'm really, so it's, I mean, yeah, it's super interesting. It forces me to rethink some of my maybe conceptions and ideas about the topic. And yeah, there are many more interesting questions I think that this raises. So I had to, in the sense, I had less lessons than advertised, but I think there could be much more if we wanted to. So yes, thank you.
Thanks. Do you mind saying a bit more about the conceptual engineering project? Because I think it's possible that we might need some sort of like disjunctive account of understanding where the sort of a disjunctive account of understanding where the sort of account you're given for what counts as understanding sort of agentive processes that involve human beings, for instance, doing science, etc., is different from the sort of understanding that you might want. So do you mind saying a bit more about, I take it that's what the conceptual engineering project is about, right?
Yeah. So I mean, that's one way of understanding. So I was, pointing at Dave's, suggestion on Friday in the debate, so that maybe we need to revise a bit some of the concepts. I think, yeah, again, I'm a philosopher, if we could have a concept that applies to all sorts of maybe agents or systems, I mean, that would be preferable. And honestly, I just at this point don't have a strong opinion on this. I guess that, yeah, I don't have a strong opinion on, disjunction. So I think we might have to revise our accounts or philosophical accounts, but I'm not sure whether we need a disjunction or not. I guess that would be my position right now.
Could you say something more about the connection with falsehood? So it seems right that it's disanalogous with how falsehood might be useful to us in models in science, but it seems like, when you say they rely on falsehood, I don't think we actually have any evidence of that, right? We know that they produce things that we take to be false, but it's not clear that they themselves have false beliefs or if they have beliefs at all. So I guess I'm wondering, like, why think that these accounts are relevant to each other?
Yeah, no, so I mean that's true that we do not always have the evidence of whether they rely on falsehood. I think there are also just the idea that not the output itself is false and that could somehow lead to understanding. So I think that at least that's one of the claims of the non-factive accounts of understanding. So it's not just that falsehood plays a role in getting to truth, but even the result that you get, let's say from a modeling exercise, is not really the complete truth. It's maybe a idealized version of the truth, and even that idealized version of the truth is, provides understanding. And yeah, can we think of what's of the output of the LLMs as being idealized version of the truth? Again, I don't have a strong opinion on this, but it's not only the justification part that plays a role in non-factivity, it's also, I think, the output itself, the conclusion, in a sense, if you think about this in inferential terms.
Hi. So I'm not sure if you would require consciousness for grasping, but I wonder whether you would require, I guess, what Dehaven calls C2, or thinking about thinking, or meta-knowledge, in the sense of an ability to question the validity of one's outputs in a way, whether that would be sufficient to be able to grasp some concepts. If you could speak about that.
Yeah, maybe. I think that's an interesting suggestion. Because really, I was really being honest when I said that this is really an issue that I think didn't pay enough attention to in, let's say, my own past research, and I think that's just forcing me to now, and I think also forcing the field maybe to engage a bit more with these with these kind of questions. Maybe I have the feeling that some of the maybe fundamental questions would still not be solved by something like maybe metacognition, because you're just in a sense, having different layers of inferences. And I think probably some of the objections to the inferential account would still apply to these different levels. So I think you can add maybe as many levels as you want, but if you really want something that's like consciousness, maybe that's going to be insufficient. But that would be my, let's say, prima facie answer to this.
Thanks. Okay, so I'm going to be a little bit skeptic, but because it's philosophy, I think I'm allowed to. I was expecting to hear where I'm worried whether even it is even possible to know whether AI is capable of understanding, as we can see them as extensions of our mind, for example, as also Dave was saying, because we are using our experience, we are using our sense of understanding to look for it in the AI. And say we make all the progress, we find all the conditions, sense grounding, without sense grounding, I don't even care. We find a way that we are convinced that the AI understands. How possible is it to dissociate their its understanding from our understanding? And let me give you an example very fast. Take, for example, Rosetta Stone. If we didn't discover Rosetta Stone, we wouldn't know, we wouldn't decode the Egyptian language. Take, for example, Marmoset language. We're not the only species that speak. The Marmoset use language. Let's say we have an AI that is trained on Marmoset language and behaves the way we find the features that we think marmots understand. Can we even say that it understands? And finally, let's say an alien comes and finds all the text the human has written, and even the model the humans have found that the humans were convinced that the model works, that understands. Can the aliens really know that the model understands?
Well, I mean, I'm not sure we need to have really, I mean, contrive maybe examples like this. I think I get the point. And I mean, quite often, an example that's often discussed in the literature is maybe like a child that you have a house that burns down, and then the chief firefighter explains maybe to the child why. Maybe it's because of faulty wiring, and so then the child knows the explanation of why the house burned down. But I mean, there's not really maybe grasp or deep understanding of why, but you still have maybe this kind of maybe belief. I guess maybe this analogy with this case and maybe some of the others you were discussing is whether maybe you have something again, so maybe like the real grasp that maybe that would be closer or akin to consciousness. And I think again, I mean, that's an issue that I think is a bit or open, but a lot of people definitely in the field now would defend the idea that maybe again, so the child would understand. So if you just possess you have a belief in a true explanation that can be sufficient for understanding, even if you don't have like more information about it. Like testimonial knowledge, for instance, can be reliable and justified, for instance.
I just have a very quick comment and maybe even a question, but could it be postulated that metacognition is understanding and it is empirically induced?
Empirically induced? What do you?
It is empirically induced by virtue of it being, right? And it's an understanding, right? In a way that what you were referring to, and all the input is semantics, right? There is a language, there's a body language, there's a DNA language. So, you know, the language of DNA is the semantics that we produce using sound, and the consciousness as the main engine of our happiness.
Well, I guess I'll have to take that as a comment and not a question. Yeah, no, I guess I should have expected that this audience would maybe push more on the grasping matters, maybe section of the argument. But yeah, no, thanks for the suggestion.
Okay, we got to aliens, we got to consciousness, we got to DNA. I think we must have just about covered it all. So let's thank Philippe very much. Finally, it just remains. Yeah.
So I want to thank Dave, who has done more than anybody else to make this meeting a success.
Well, I was going to thank a few people from NYU. For example, Holly on the soundboard, who has been totally amazing. Everyone has been saying how great the sound has been on the live stream and so on. So thanks a lot, Holly. And Joe on the camera and running the Zoom and the slides and the catering and so much. Our postdocs, Matthias and Luke, have done a million things, running around to solve 1,000 problems. And Jack Mikaszewski, actually, who's not actually here this weekend, but was the one who did all the groundwork with the registration and organization of lecture halls and so on to make all this possible. So thanks to Jack as well.
Yeah, I want to thank also the admin team from the Presidential Scholars in Society and Neuroscience at Columbia. So Melinda Miller and Joseph Zulik, who did a lot for the organization and planning and registration as well. So.
And since Ned already thanked me, I want to thank Raphael for an amazing job in the what's that? Oh,
also some of the students from
okay.
Columbia who helped out. So Veronica Bosio, Sayoko Blodgett-Ford, and Ashley Ding. So thanks also to them a lot. Thank you.
And we got to thank Ned for doing it. Get up here,
Of
Ned.
course, yes.
Doing an amazing job. So, thanks so much to all our speakers, all our panelists, all our presenters, all our audience. It's been an amazing time. Thanks so much for coming. Okay,